Question 1. First of all, differentiate. And now set that equal to 0, as it says here, dy dx equals 0. So I can divide everything by 3. And now I can factorise. So that means that x equals minus 2. Now, it must be pointed out that later on I'm going to use dy dx, and I don't want to use that, and I don't want to use that. I definitely want to use that. So I'm just going to write this out more clearly over here. Just so I don't get confused. Okay, so my value for x was just negative 2. That works in both brackets to make both brackets 0, so you only get one value. Classify the points that correspond to these x values. Right, so we write down negative 2, and we want 2 surrounding values. So I'm going to pick negative 3 and negative 1. I could have picked any number to the left of negative 2, and I could have picked any number to the right of negative 2. But those values will do fine. Now, this one, remember I'm working out dy dx, and I said I would need to come back to this formula now. This is the formula I'm going to use to figure out what these things are here. So for this one here, I'm going to do 3x squared, 3 lots of negative 3 squared, plus 12x plus 12. So that is 3 lots of 9, 27, take away 36, plus 12. So that is negative 9 plus 12, that is 3. For this one, I'm going to do the same. I'm going to go 3 lots of negative 1 squared plus 12 lots of negative 1 plus 12, which is 3, take away 12 plus 12, which is also 3. Now the important thing is that this is positive and this is positive. So when it comes to classifying the points that correspond to these x values, I need to draw something with, first of all, my stationary point, my gradient 0. And then on the left hand side I want a positive gradient going into it. So that is going to be like that, a positive gradient. And then afterwards I'm going to have a positive gradient. So it's going to be like that. So this is what we call a point of inflection. Find the corresponding y value. So we need a formula that tells us what y is. So we go back to this thing up here, the very top. Y equals x cubed plus 6x squared plus 12x plus 8. And we are going to put in our value of x that we found out in the first part of the paper. So x is negative 2, we can put into here. So that gives us a y value of 0. So your coordinate then is going to be negative 2 was the x value and 0 was the y value. Now to sketch the curve we need this point here. Negative 2, 0, so that is going to be like there. You need to label that point. And we want this point of inflection, so we know it's going to go up to that point. It's going to flatline at that coordinate, and then it's going to go up again. So I just like to do a little area around there. I just want that. I know it's going to go like that, and then I'll flesh that out a little bit more now. So basically I know my graph looks something like that, and that's the end of that question. Question 2. Differentiate first. Now set that equal to 0. It says dy dx equals 0 here, so that equals 0 gets carried across. Now divide everything by 12 to make things a little bit easier to manage, and we're going to factorise. So we've got a common factor of x squared, so that's x plus 1 there. Now we've got two solutions here at least. Right, we've either got this comes to 0. Now if x squared equals 0, then that means that x also equals 0. Or we've got this equals 0, so if x plus 1 equals 0, then x equals negative 1. So we have two solutions. And again, as I've done on previous questions, I'm just going to highlight the fact that I'm going to use this formula later on. I'm not going to use this, and I'm not going to use this. So my dy dx equals 12x cubed plus 12x squared, not the x cubed plus x squared. That's very important. Let's highlight that. Okay. Classify the points that correspond to these x values. Now we've got two x values. We've got negative 1, and we want something that is on either side of negative 1. And then we've got 0, which is going to appear here, and we want something that is going to appear on either side of 0. Now this value in between is going to be on the right hand side of negative 1 and on the left hand side of 0. So this is where we put our dy dx's. Right, so we know that when x equals 0, dy dx equals 0, so that is a 0 there, and we know that when x is negative 1, dy dx is 0. So we need to find these other values here. So I'm going to put something here, negative 2, say. This one here, well, something in between negative 1 and 0 is negative 1/2. And then something to the right of that, well, 1 is the best value I can think of for that. Right, to work out my dy dx, I have to use this formula here that I highlighted before. So it is 12 lots of negative 2 cubed plus 12 lots of negative 2 squared. So 12 lots of negative 8 is negative 96. 12 lots of 4 is 48, so that is going to be negative 48. Right, negative 1/2. Now you might like to just put this into a calculator, but you can do it with without 2. So it's negative 1/2 squared. So negative 1/2 cubed is negative 1/8. So that'll be negative 12/8, that bit there. And that will be 12 lots of negative 1/2 squared. Negative 1/2 squared is a quarter, so 12 quarters is 3. So really that is 12 over 8 is 1.5. So it's negative 1.5 plus 3, so it's 1.5. The important thing is that it is positive. It doesn't really matter what the value is. So that's where I got that one from. And the last value is this one here. So I'm going to go 12 lots of 1 cubed plus 12 lots of 1 squared. 1 cubed and 1 squared are both 1, so that's 12 plus 12 is 24, and the important thing is it's a positive. Right, pick your first 3 values, the ones that are surrounding your stationary point. Now your stationary point is this one here. Your first 3 values are those 3. So we've got a negative gradient, a down the way one, then we've got a stationary point, then we've got a positive gradient, so it's going to go up the way. So it's going to go like that, then it's going to go like that, and then like that. Negative, 0, positive. That is called a minimum point. Go back here, and then we look at our second stationary point, that's this thing here, and we look at the surrounding points. And notice this point is used in both. So we've got positive, 0, positive. Positive goes up and to the right, like that. So we've got positive, 0, positive. So this means that this is a point of inflection. Okay, find the corresponding y values then. So y equals, right, we've got 2 values of x here, 0 and negative 1. So we plug these into a formula involving y, which is this here, y equals 3x to the 4 plus 4x to the 3. So that is negative 1 or 0, I'll pick negative 1 first. So that's 3, take away 4, negative 1. So it's negative 1, negative 1. This one here, y equals 3x to the 4 plus 4x cubed. So that's 3 lots of 0 to the power 4 plus 4 lots of 0 cubed. So that is 0. So your value there is 0, 0. So, our 2 points there on our sketch are 0, 0, and they are negative 1, negative 1. So at the first point, the negative 1, negative 1 is this thing here. So I'm just going to kind of sketch that in a little bit. I'm just going to put that that's a minimum point like that, just like this, a miniaturized version of that. The second point is this point of inflection from that one before. So that's going to look like that. Now if we hook those 2 up, it should look like that. Now I haven't done a very good job of showing my flat line there, but it's meant to be a minimum and then a point of inflection and then that there. Question 3, differentiate. Now we set that equal to 0. I'm going to divide by 4, so that is 3x squared, take away x cubed. Factorise. Now, yep, so that's x squared, 3 take away x equals 0. So my 2 solutions, either x equals either x equals 0 or x equals 3. Just as a reminder to myself, I'm going to write that my dy dx equals the original equation, not this one, not that one. Classify the points. So we've got 2 points, 0 and 3. So there's 0, there's 3. We need a point in between 0 and 3 and a point to the left and right of each of those numbers. So dy dx, we know that that one is 0 and that one is 0, so this one I'm going to pick -1, 1 and 4. So this one here is 12 lots of 4 squared, take away 4 lots of 4 cubed. So that's using this expression to generate my value of dy dx. So 12 lots of 16, 192, and this is 64 times 4, it's 256. It doesn't really matter what this value is, but that it is negative is important. This one here, 12 lots of 1 squared, take away 4 lots of 1. One cubed. So that comes up as 8. Okay, so -1, I'm going to do 12 lots of -1 squared, take away 4 lots of -1 cubed. So that'll be 12, take away, that'll be -4, so that'll be 16. But the important things are that these are positive. So we have got, on the first one, we've got a straight line. We've got a positive, a 0, and then a positive. So it goes positive, and then positive. So that is a point of inflection. Where our x-coordinate is 0. Now we're looking for when our x-coordinate is 3. So we've got a positive, a 0, and then a negative. So it goes positive, 0, negative. So that is a maximum. Right, so find the corresponding y values. Y equals, we need to go back to our original expression, 3 plus 4x cubed. Take away x to the power 4. So we want our x values. So our two x values that gave us 0 were 0 and 3. It's from here, yeah. 0 and 3. 3 plus 4 lots of 0 cubed. Take away 0 to the power 4 is 3. So that gives us the coordinate 0, 3. And the other coordinate where x is 3, y equals 3 plus 4 lots of 3 cubed, take away 3 to the power 4. So that is 3 plus 4 lots of 27 is 108, and 3 to the power 4 is 81. So that is 111 take away 81, that is 30. So we've got 330. So for your graph, those two coordinates, 0, 3, and 330, that's where all the stuff happens. Doesn't have to be to scale, obviously, it's just in, make sure it's in the right quadrant. Right, first of all, on the left we have a point of inflection. So we're going to go on this graph like that. I'm just drawing a little bit, I'll flesh it out further in a minute. And then we've got a maximum, and the maximum is the second one. So the maximum goes here. Now if we join them two up, it is going to look like that. Point of inflection, maximum, those are the two coordinates. Question 4. Differentiate first. Okay, set that equal to 0. Right, we're going to divide both sides by 15. Now, first of all, x squared could equal 0, which would mean that x would equal 0, or this bracket could equal 0. X squared take away 1 equals 0, that means that x squared equals 1. Now, x doesn't just equal 1, remember that square roots have two answers, plus or minus, so that means x squared, x could be plus or minus 1. Just going to write this formula again, just as good practice. Okay, classify the points that correspond to these x values. So we have got three values here. We've got -1, we've got 0, and we've got 1, and we want a point on either side of them. So we want -2. I'm going to have to pick -1/2 there to go in between there, 1/2 there, and how about 2 there? And we're going to put them into this formula. So the first one, we want 15 lots of 2 to the 4, take away 15 lots of 2 squared, which is 2 to the 4 is 16, so that's 240. Take away 15 lots of 4, that is 60, so that is 180. Positive 180. I might as well put these values in now as well. These all come up with zeros for their dy dx's, for their gradients. This one here, plug in a half into each of these. So 15 lots of 1/2 to the power 4. Take away 15 lots of 1/2 squared. So 1/2 to the power 4 is a 16th, so that will be 15 16ths. Take away and 1/2 squared is a quarter, so it'll be take away 15 quarters. Now I'm just going to convert that to 16ths rather than quarters, so I'm going to put that as 60 16ths. You can do all this in a calculator. I'm just doing it like this because I'm without a calculator right now. So -45 16ths. It doesn't really matter what it is, it just matters that it is a negative. This one here, -1/2 squared. Sorry, 15 lots of -1/2 to the 4. So that is going to be like this one, but it is going to come out. Oh, it's going to come out the same because -1/2 to the power 4 is still going to be 16, a 16th. So that's going to be 15 16ths. I know that. And this one here, 15 lots of -1/2 squared. Well, -1/2 squared, because of the positive power, it's still going to come out in the same way. So that's going to come out 60 16ths. So it's going to be the same value. Okay, and finally -2. Well, the negative values are coming out the same as the positive values because they're being squared or done to the power 4, so this is also going to be positive 180. So we have three values to look at. We've got 3 points where the gradient is 0. So the first one, we've got positive, 0, negative. Positive, 0, negative. The first one is a maximum point. Then we've got negative, 0, negative. Negative, 0, negative. So that is a point of inflection. Then we have got negative 0, positive. So that is a minimum point. Okay, so find the corresponding y values. Go back to our original expression. It's this here that we're going to use. Copy that down. So I'll copy that down here, and I'm going to pick my three values. So first of all, negative 1, then 0, then 1. So I'll just write these down while I remember them. And then 1. Right. Negative 1 to the power 5 is negative 1, so that's negative 3. Negative 1 to the power 3 is negative 1, so that is going to be, take away negative 5, so that's going to be like plus 5, so it's going to be 2. So there's one of my values. One of my coordinates is negative 1, 2. Right, my second one, that's just going to come to 0, isn't it? So this is going to be 0, 0. And the final one, 3 lots of 1 is 3, take away 5 lots of 1 is 5. So that's negative 2. So we've got 1, negative 2. So our 3 points then. Sketch the curve in part D here. 0, 0. We've got negative 1, 2, so we've got a point here, and we've got 1, negative 2, so we've got a point there. Now let's have a look at what happens at each of them. First of all, label them. Negative 1, 2, 1, negative 2. Right, so we get a maximum point, a point of inflection, so let's just do the maximum point first. It's going to look like that. Maximum point, point of inflection. And a minimum point, so that is going to go like that. Like that. I haven't really drawn the point of inflection that clearly, so let's just, there we are. That looks a bit more flat now. Okay, differentiate. Right, it would help if this was in a form that didn't have this bracket in, so it would be 8x cubed, take away 4x to the 4. So this is going to be 24x squared, take away 16x cubed. We set that equal to 0, so and then divide by 8, so that would be 3x squared, take away 2x cubed. Factorise. Okay, so either x squared equals 0, in which case x equals 0, so there's one of our values, or 3 take away 2x equals 0, that means that 2x equals 3 and x equals 1.5. Our equation for dy dx, I'll just copy this across so it's more visible. There we are, that's from there. Right, classify the points. So we've got 0, we've got 1.5, we need a point in between. We'll pick 1, we'll pick 1 there, 2 there, and we'll pick negative 1 there. So we know that the point 0 gives us a dy dx of 0, and we know the point 1.5 gives us a dy dx of 0. So we just need to put these three values in now. So this is our formula, 24x squared take away 16x cubed. So 24, 2 squared take away 16 lots of 2 cubed. So that is 24 lots of 4, that is 96. 16 lots of 8 is 128. So the important thing is here that it's negative. It is going to be negative 34. Sorry, negative 32, isn't it? Okay. Right, this one. We've got 24 lots of 1 squared, take away 16 lots of 1 cubed. So that is going to be 24 take away 16, which is 8, positive 8. This one, 24 lots of negative 1 squared, take away 16 lots of negative 1 cubed. 24, 16 lots of negative 1 cubed is negative 1, so that's take away negative 16, that's like plus 16, so that's 40, so that's a positive. So your 3 points then are positive, 0, positive. So that is a, oh, I've done that wrong. Positive, 0, positive. That is a point of inflection. And then we've got positive, 0, negative. So positive, 0, negative. So that is a maximum point. Okay, find the corresponding y values. Y equals, so we go back to our original equation, y equals 4x cubed, 2 take away x. You can also use this is the same thing. 4x cubed, 2 take away x, and we put our 2 values in. So we put in 0, so that's going to come up with 4 lots of 0 times 2, so that's going to be 0. So one of your solutions is 0, 0, and one of your solutions is going to be where x was 1.5. So we want y equals 4 lots of 1.5 cubed times 2 take away 1.5. Right, this is going to be 4 lots of 1.5 cubed is 3 over 2 cubed, so that is 27 over 8 times a half. So that is going to be 4 times half, that's 2 lots of 27 eighths, or 27 quarters, which is 6 3/4. So your other value is 1.5, 6.75. Okay, sketch the curve. Okay, so our points are 0, 0 and 1.5, 6.75. So the 0, 0 is the left-hand one, that's your point of inflection. So let's draw a little bit of that in, like that. And the right-hand one is your maximum, so that is going to be like that. Just drawing a little bit of that in there. So your graph is going to go like that. Number 6. First of all, differentiate. Set that equal to 0. Divide everything by 3. Okay, so that is going to be x take away 1. As this is a quadratic, we need to factorise it into 2 brackets. So that means x equals 1 is our only solution to that. Let's just copy this across. dy dx equals 3x squared, take away 6x plus 3. So that we use this one and not this one or this one. We've only got one value to go, so that is x is 1, and that gives us a dy dx of 0. We need a value on either side, so I'll pick 0 and 2, and I'm going to use this expression here to generate my values. So it will be 3 lots of 0 squared, take away 6 lots of 0 plus 3, so that is 3. Positive 3. This one here is 3 lots of 2 squared, take away 6 lots of 2 plus 3. 3 lots of 4 is 12, take away 6 lots of 2 is 12 plus 3, so that is 12 take away 12 plus 3, that is 3. Positive 3. So this goes positive, 0, positive, positive, 0, positive. This is what we call a point of inflection. Find the corresponding y values. Well, we only have one y value to find. We need to go back to our equation with y involved, so it's this original thing. Copy it all out. Y equals x cubed, take away 3x squared plus 3x plus 1. So then we plug in our value of x that we found in here. X is 1. 1 cubed, take away 3 lots of 1 squared plus 3 lots of 1 plus 1. So that is 1, take away 3 plus 3 plus 1. So that is, in total, 2. So your solution, your coordinate is 1 and 2. 1, 2. So we draw a little sketch here for the bit where we're asked to sketch the curve. 1, 2. And we know it's a point of inflection. So it is going to look something like that.